All right, this is 5-3 day 2. Another one of those learning targets for the second day. Doesn't really offer anything super new or different, right? The concept is still solving. What I'm trying to do is just equip you with notes where you have examples on like every possible type of trig equation that I could expect you to solve, okay? On this one, what I'm hoping that you're seeing is the kind of the new element to this one is that 3t. You're going to see that that's not really something we deal with until the end. So I add 1, and then I divide by 2. So we're still getting to this same form where, you know, I've got a trig function of something, right? Cosine of, in this case, 3t as opposed to t equals 1/2, okay? But I'm in a position where I can take an inverse because I have the cosine value on the other side. I need to do inverse cosine of 1/2. Now, one thing I want you to pay really close attention to when you see this happen. A cosine graph typically has a period of 360, and again, other than one example today, I'm just going to talk degrees the whole time, just to keep it as simple as possible. Okay? Like we saw this happen when we did graphs, that 3 takes the period and it makes it 3 times as short. Okay? I'm going to hang on to that for really the very last step, all right? So now when I do my inverse cosine, okay, here's what I end up with, is I have my two possible solutions. The one I will get from the calculator is 60. Okay, if you go to the calculator and do inverse cosine of 0.5, it will tell you 60. Great time to review these different rules we have for different trig functions. All right. Honestly, if you can't remember, I would pause and go check your notes because you have an example from the first day. What is the rule for cosine to get the second solution? Cosine is always 360 minus your first. Okay? Now we're in a position where we're going to deal with this 3. I get 20 degrees. This whole side is really 300. I divide by 3 and get that t equals 100. Obviously, I really needed to look at the second possible set of solutions because it's giving me different ones. Okay? Now, this problem wants all the solutions from 0 to 360. Okay? Typically, from what we saw on the first day, this means go ahead and add or subtract 360, or unless it's tangent or cotangent, add 180, or subtract 180. That's not the case here. Okay? The period of this graph changed, so if you want to go look for more solutions, don't add 360. Add 120. And you'll see over here, I will get 2 more. And then over here, I add 120, and then I add it again, and I get 2 more, and I end up with 6 solutions total. Okay, so if you see that happening with a value for b like 3, it's varied some with most of the problems we did, but we typically got 2 solutions. If you have a value for b there, you're probably going to get more than 2. All right, we see the same thing going on here. Okay? This is a tangent. It has a value for b of 1/2, so I'm going up here, and you should do the same thing. Now this just says general solutions, right? So this is going to have, really it'll be plus 360 times n. Right, that last one we just did was a little bit different because it just said from 0 to 360. Just give those solutions. Here it doesn't specify an interval, so we have to put the solutions in kind of a general form. The first couple steps don't really vary at all. Subtract 3 and then divide by 3, and we get to that. Right? We got to get ourselves set up with an equation where we can do an inverse. Okay? In this case, it would be inverse tangent. And I'm all set up for our two possible solutions. Okay? Again, going off the calculator, if I do inverse tangent of -1, the calculator will tell me -45. Okay? Now remember over here, the rule with tangent is 180 plus your first answer. Okay? 180 plus your first answer. Here's what that would leave us with. I multiply both sides by 2, and I get to the solution of -90 degrees, though I don't think that's the one that I'm going to leave my answer in. I really don't. Over here, 180 minus 45 would be 135 times 2. And I get an answer of 270. Okay? That's between 0 and 360, so I like that number. All I'm going to do with that is I'm going to tag onto it plus 360n. Right? That solution I like. 270, add or subtract 360, because that was our period. Okay? Now I can do that again here. Notice what happens when I go back to my first. I add 360, and I end up at 270, which I already knew was a solution. Remember, when you account for your two possible sets, sometimes they overlap, and one of the two solutions that you solve for doesn't give you any new ones. Most of the time they do. So here I'm kind of like, okay, really all I would have to have is this. 270 plus 360n. I did it again here, where I'm trying to make us think that we're going to talk radians. And again, on one of them I will, but not this one. Okay? This is going to be another one that will take on a little quadratic form. Okay? With a trig substitution as well, and those can be a little tricky to do. I'm hoping that you're looking right here. I've got an identity that will work well. Secant squared is 1 plus tangent squared, which is ideal for this equation because it puts us all in tangent, which is good. Okay? Anytime you're solving or simplifying, verifying, if you can somehow make adjustments to get your expression or equation all in terms of a single trig function, that's a good thing. Okay? This is going to take on one of those quadratic forms. I got tangent squared minus 2 tangent. I'll subtract 4 and then add 1. Right? Like anytime we have something that's a quadratic, we'd like it set equal to 0. And then it'll be time to factor this. And we are looking for minus 3 and plus 1. So always important to remember that once we have it factored, the reason we did that is we're basically taking this bigger, more complicated equation and we're splitting it up into two smaller equations that are going to be a lot easier to solve. But between the two of them, they're going to give us all of our solutions. Now notice here, there's nothing going on with tangent of x. So in terms of the period, which I don't think it's a bad idea when you're getting like additional solutions, it's always the number that you're going to add or subtract. And it varies. Like that's the thing I'm trying to emphasize on all these is it depends on your trig function, depends on your value for b, but from one problem to another, it's pretty common that it's going to be a different value. In this case, it's 180. So here, if I were to do inverse tangent of 3, I get 71.6 degrees. Okay. Now, again, I don't know if this is going to give me any new solutions or if it's going to matter, but I want you in the habit that you just do it every time. 180 plus your first answer will set you up to get the possible second set. You should just do that every time. Okay? Like right here, if I do my inverse on the calculator, it's going to give me negative 45. Now that's not going to be an answer I want because this was a problem where it said get all the solutions that are between 0 and 360. But I do want that number here because down here I'll go 180 plus that first answer, right? And it has to be the exact answer that the calculator gave us for that rule to work. Okay, so now looking up here, 71.6 is an answer between 0 and 360, so I want that. Now if I add 180, which it looks like I'm going to be doing for the second solution, I get that x equals 251.6. Okay? I can add it again, but that's going to take me beyond 360. So that first factor gave us two solutions. Okay? Decimal approximations that we got from our calculator. Here, it kind of seems like the two possibilities are really leading to the same case again. If I add 180 here, I get 135, right? Which is a solution that I want. I don't want negative 45 because that was less than 0, but I do want 135. This right here is going to give me the same thing, right? That's going to give me the 135, so they're lining up here. If I add 180 again, though, which I can do because that's the graph's period, I'll get 315, and those would be the two solutions that I'd be looking for, 135 and 315. All right, if you've been using your calculator for these, this is the one, get your mode, switch to radians. Okay, if that's the case, use degrees as your default, and I'll give you a heads up on those problems where you're going to need to switch. Okay? So here's what we're after here. Right off the bat, I want to make note that the period of this graph is 12. Okay? That's coming from 2 pi divided by pi over 6. And right here, I want to kind of just look on a real basic level graphically at what this is doing. It's a cosine graph. It starts up at the top in January, because this is representing the sale of ski equipment. And then it bottoms out in the summer, and then picks up again back in the fall. Okay? We are concerned with the 2 points, and we should find, if the data really does follow a cosine model, 2 points in the year where the sales will hit 7,500 units, and the time in between should be when it exceeds. So for starters, I want to find the 2 points where it hits 75. Okay? Now, read this carefully here, that the units are in hundreds, right? It's really common on one like this that I see that it gets set equal to 7,500. You just want it set equal to 75. Okay? Now, even though it's a word problem, the method doesn't change. So I'm trying to get really this cosine of pi over 6t. I want that by itself. When I divide by 32.5, I get to that, and I'm exactly where I want to be. All right. Obviously, dealing with decimal approximations, when we're doing, application questions, that's typically how it plays out as you deal with approximations. Okay. Now, remember my period here is 12. We'll get to that in a minute. But we get to this point because it's time to use inverse cosine. Okay, inverse cosine of 0.514. Okay, straight up just from the calculator. Okay, that's a number you should just copy down. It's 1.03. Over here, to get your second one set up, you should do 2 pi minus 1.03. That would equal 5.25, and now on both of these, they just need to be divided by pi over 6. That would give us 1.97, which according to the context of this problem, that would be about February. And then over here, take 5.25 divided by pi over 6, and then you would get 10.03, which according to this model is about October. Okay, so to answer the question, what period of time are the sales going to exceed 7,500 units? Well, that's why I was kind of looking at this little graph of the whole situation. Okay, it looks like October is when the sales will pick up. Sometime in October, they will hit 7,500, and then they should exceed that level through February when the sales start to drop off again. All right, back to degree mode. No context to this one. Okay, these last two are a little bit shorter and easier. Those last two ones that we solved, those had a lot going on and had quite a few steps. Okay, but really here with sine, we haven't seen kind of what we would call a multi-angle. You might hear the book refer to that. That means it's got a value for b that's not 1, and I should be keeping track of things here. You don't have to write it down. I'm just, if you'll forget without writing it down, then I would. All right. But here we are at a point where it is time to do inverse sine. And again, that just doesn't, that's kind of what we're after every single time that we're solving, is to, like the first things we do is just rearrange the equations so we can do the inverse. Okay? 23.6 degrees if you do inverse sine of 0.4, right? That's what's going on at this point as we're solving, is I would type into the calculator inverse sine of 0.4, right? I got a sine value of 0.4, give me that angle. This is why I threw in one with sine, is to remind you that its rule is 180 minus your first answer. Okay? Now over here I'm going to divide by 3, and I get 7.8 degrees. 180 minus 23.6 is 156.4. Divide that by 3, and I get 52.1. Okay? Those are both between 0 and 360, so I'm going to take those solutions. However, we can add 120 to get more. 127.8 is less than 360, and so is 247.8. Bump over to our second set. How about 172.1? We'll take that. And then how about 292.1? Okay? Giving us 6 solutions total. Alright, last one. This is kind of an interesting little one that I would want you to see, because it's got kind of an element of, you know, what would you do? Solve this from 0 to 360 and stay in degrees. Kind of a weird one. I just threw it at the end because it's good to see. What I would do here is if I divided both sides by sine of x, I would get this. Cosine over sine, which we know better as cotangent. Okay? Now that's a little bit interesting, because I think in the first day we saw a little bit of cotangent, but other than that, it's been tangent, sine, or cosine. We haven't seen secant or cosecant at all, and for the most part we could really avoid them. Not totally, but more often than not. So like right here, what I would do to kind of get it back to something that's more familiar is I would switch that 2 to a half, which you can do as long as you use the reciprocal trig function and make it tangent. That looks much more similar to what we've seen. Okay? I'd be all set up to do inverse tangent of a half. Calculator would give me 26.6 degrees. As always with tangent, I would add my first answer to 180 to get my second. That would give me 206.6. Okay. Now, I should have pointed out here that once I saw that this was tangent, our period is 180, so that's the number. Once I get to this point where I'm like, hey, I've got 2 answers, I can add or subtract 180 over and over again. We've essentially already done it once, where we added it to get 206.6, and if we add it again, we get 386. This one will just have 2 solutions, that one and that one.